All right, we're going to continue talking about proteins. The last lecture dealt primarily with the building blocks of proteins. Now we're going to actually talk about proteins themselves. So proteins are just lots of amino acids linked together by peptide bonds. So when you get all these amino acids that are linked together, pretty complex structures exist. And I highly encourage you to look in your textbook when I talk about the different structures of protein structures. So look in your textbook for pictures because they're very useful. So the primary structure of a protein, when you hear that term used, primary structure with regard to proteins, this is just the amino acid sequence. So, primary structure, I'm going to use abbreviations for the amino acids. Ala, ser, glycine, ser, val. So that's just the primary structure, the order in which these amino acids are linked together. Now, the glue that holds the primary structure is peptide bonds. So, held together by peptide bonds. And we learned in the last lecture that peptide bonds are just amides. So primary structure is the amino acid sequence. Kind of a review. You could have an isomer of this. It's kind of an application of the word isomer to biochemistry. But it could have a completely different function. So let's say this is just a segment of protein. If I had the isomer, it would have the same amino acids, but just connected in a different order. So you have ser, val, ser, ala, gly. So that would be an isomer of that protein. Just kind of interesting. But that different order of amino acids could drastically differ the function of the protein. And while I'm talking about this, let me put a term. I'm going to put this at the top of your paper. Enzyme. A lot of proteins are enzymes in your body. And enzymes are just biological catalysts. So we learned about catalysts way back in Unit 2. Remember that catalysts lower the activation energy of a reaction. They also speed up the reaction, so they increase the rate of reaction. Okay, so we're talking about proteins. We're talking about the different levels of structure within proteins. There are 4 levels: primary, secondary, tertiary, and quaternary. We've talked about primary. Primary is just the basic sequence of amino acids. How are the amino acids connected? Secondary structure with proteins refers to how the chain of amino acids is arranged. How the chain of amino acids, I'm going to abbreviate amino acids AA, is arranged. And there's some nice pictures in your book of this. This is the secondary structure is held together by hydrogen bonds. And if you're a little fuzzy on hydrogen bonds, flip back to Unit 5 and review hydrogen bonds. The examples of secondary structure that we see an alpha helix and a beta pleated sheet. So an alpha helix is as if you have a phone cord. You know, those, not a cell phone cord, old-timey phone cords that look like this. That over time get twisted and can become very annoying. So this is an alpha helix, and the hydrogen bonds take place within the backbone of the protein. So when I say backbone, remember that the general structure of an amino acid, we have NH2, CH, C double bond L. Let's say this is a protein and it's connected to another amino acid. And it just keeps going on and on. This protein, the R groups are coming off here, 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 and here. The backbone is this blue part that I'm highlighting. So it's just kind of the repeating amide, carbon bearing the R group, amide, again and again and again. So that's the backbone. So the hydrogen bonding in the alpha helix occurs between the backbone. Now the beta pleated sheet, look to your book for a nice picture. This kind of chain is kind of wrapped on itself, so it looks like this. So it's flat, and again the hydrogen bonding occurs between the protein backbone. So that's secondary structure. Tertiary structure. This is the overall 3D shape of the protein. Overall 3D shape of the protein. So, does this protein look like a ball? Does it look like a dumbbell? Does it look like a cube? Does it look like a long rod? The tertiary structure is held together by a lot of different types of bonding. Held together by hydrogen bonds. This is between R groups now, between B/T R groups. Disulfide bonds. And that's S to S. Ionic bonds. So plus and minus attraction. Sometimes you'll hear that referred to as a salt bridge. Hydrophilic interactions. So water-loving interactions. So these are typically polar R group to polar R group, and then hydrophobic interactions. And this would be nonpolar to nonpolar. So the tertiary structure is the overall three-dimensional shape of the protein. It's held together by many different bonds, but the bonding occurs between the R groups. So all proteins have primary, secondary, and tertiary structure. Not all proteins have quaternary structure. So quaternary structure is when two or more subunits are required for protein activity. So the bonding in quaternary structure can be H bonds, ionic bonds, and this kind of goes beyond what we need to know. Disulfide. But if you have a protein that's described to you as saying, 4 subunits are required for protein activity, what type of structure is this? That would be quaternary. Hemoglobin is an example. Requires 4 subunits for activity. Now, 4 is not the magic number. You could have a protein that just requires 3 subunits for activity, and that would also be an instance of quaternary structure. So as long as 2 or more subunits are required for activity, that's quaternary structure. Okay, so that is protein structure, primary, secondary, tertiary, and quaternary structures. Look in your book for pictures. There's some very helpful pictures and illustrations. Let's talk about essential amino acids and non-essential amino acids. You'll hear this with regard to dietary considerations. So, essential amino acids must be obtained from the diet. In other words, your body cannot make them. Non-essential amino acids can be synthesized in the body. So you don't need to obtain them from your diet. So essential amino acids must be obtained from diet. The body cannot make them. So it's interesting. Humans have a certain set of essential amino acids, and cats have different essential amino acids. So it varies from species to species. So you want to make sure that you're getting the correct amino acids in your diet, so that your body can use them as building blocks to synthesize proteins and so on, so forth. Right, the last topic of Unit 6 deals with proteins, and this is denaturing proteins. So this is when you denature a protein, you disrupt secondary, tertiary, and quaternary structure of protein. So you disrupt the secondary, tertiary, and quaternary structure of the protein. Protein loses activity. So it would no longer function the same way. So if you are working on a protein or studying a protein that helped catalyze oxidation of alcohols, if you denatured it, it's no longer going to be able to oxidize these alcohols or aid in the oxidation of these alcohols. So there are a lot of ways to denature proteins. The first method is heating. So if you think, when you cook proteins, when you bake anything, you are denaturing those proteins. They no longer work. So when you cook eggs, you're denaturing the proteins in eggs. They're no longer going to work the same, and it's irreversible. So frying eggs would be an example of denaturing by heat. Also, another way to denature proteins is agitation. So there are many different levels with eggs when you whip them. If you think of beating eggs, you can really get into the science and chemistry of the different levels of beating eggs. But there are books written on this, where how do you get firm peaks? How do I make my meringue just right? But when you agitate proteins, when you beat them or shake them, you are denaturing those proteins. They're not going to work the same. So you're disrupting the secondary, tertiary, and quaternary structure of these proteins. Another way to denature proteins, detergents. So you wash your hands. You can denature bacterial DNA, or denature the bacterial proteins so that they can't survive. So denaturing DNA. Another way to denature proteins is with organic solvents. So when you go to the doctor's office and they are giving you a shot, they use isopropyl alcohol on your skin, right? So they're trying to kill off any germs, and that occurs by denaturing proteins. Acids and bases can be used to denature proteins. Lastly, inorganic salts can be used to denature proteins. One that's used commonly is silver. So I had a student one time who just had an aha moment when we talked about this in class. She had a really bad spider bite, and it was very infected. And the only way that they were able to get rid of this infection was to use silver. And so the silver was denaturing those proteins of the germs that were living there. So it was denaturing the proteins, it was killing these germs, and so her spider bite could heal. But a lot of times, silver is a very effective treatment. If you happen to, be buying Band-Aids, if you look in the pharmacy or wherever, Target, Walmart, wherever you get your Band-Aids, they do have some Band-Aids that have silver. They're immersed in silver. So they're more expensive, but the premise is that these inorganic salts will denature proteins. So it's an effective way of preventing germ growth. So what happens to protein function when it becomes denatured? Right, we talked about this with the definition. So the function is no longer there, so it no longer functions like it used to. So that concludes Unit 6. I know that you're very sad because this is the last unit. This is the last lecture you'll hear for this class. But with that said, there's a lot to be done to prepare for the final. I'll just go through this now because I know that a lot of you have questions about this. When you come in to take your final, so let's say it's final day, you're going to be given either the Unit 6 exam or the cumulative final. So the Unit 6 exam has 35 multiple choice questions and some short answer questions. The cumulative final has units 1 through 5. There it says 75 multiple choice question. It has 75 multiple choice questions. So that's 15 questions per unit. And it goes in chronological order. So it starts off Unit 1, 1 through 15. Unit 2, 16 through 30, and so on and so forth. So depending on where you sit, it determines whether you get the Unit 6 exam or the cumulative final. When you're done with either one of those, you come to me and you hand in your exam. I will give you the other one that you need. So if you started off on the cumulative final, when you're done with that, then I will hand you the Unit 6 exam. Please bring a number 2 pencil because we will be using Scantrons. So Scantrons will be used. So we haven't been using Scantrons for the previous exams, but I wanted to let you know that we will be using Scantrons, so bring your pencils. And you can write all over the finals. I know in some classes you can't write on the finals, but we allow you to write on the finals, so keep that in mind. A lot of students have concerns whether they can finish these exams, and because you have an hour and 50 minutes, so 1 hour 50 minutes. And I have had students finish in 45 minutes. I've had students finish in 30 minutes. I've had students take the whole time. Typically, the way it works is if you take the whole time for your exams and quizzes, you're going to take the whole time for final day. That's just the way it is. And you need to pace yourself. I will let you know how much time you have remaining. You also will be given a periodic table. So you'll have a periodic table and bring a calculator. So if you don't have a calculator, I'll provide one, but a non-graphing calculator. So that is it for the final. Once you're done with that, you're done with the course. So it's been a pleasure working with you all, and I will see you on the final day. Please email if you have any questions, or save your questions for the recitation period. We do have one more recitation period left. So think of any questions you have. All right, it's the last time. I'll see you later.